Unit 5, we're going to be studying similarity, and so we're going to start the unit talking about ratio and proportion. If A and B are two quantities that are measured in the same units, then the ratio of A to B is A over B, or A divided by B. Pretty sure you've known that for a long time. And please remember, a ratio should always be written in simplest form, which means there will be no units, right? Because if I have the same units in the numerator and the denominator, then those units will cancel each other out and there will be no units. All right, we also talk about what's known as an extended ratio. What is an extended ratio? It compares three or more numbers. In the extended ratio, A to B to C, the ratio of the first two numbers is A to B, or A over B. The ratio of the last two numbers is B to C, or B over C, and the ratio of the first and last numbers is A to C, or A over C. All right, so let's see how we're going to use that extended ratio concept. The lengths of the sides of a triangle are in the extended ratio of 3 to 5 to 6. The perimeter of the triangle is 98 inches. What is the length of the longest side? Okay, well, what we're going to do, since we know the ratio of all the sets of two sides together, we're going to label one side 3x, and we're going to label one side 5x, and we're going to label the other side 6x. Whenever you're given the extended ratio, this is how you want to proceed. All right, and now we're going to use the information we have about the perimeter, right? So we know the perimeter is just the sum of the side lengths. So we're going to say 98, which is the perimeter, is 3x plus 5x plus 6x. And now we're going to just simplify this, so we get 98 equals 14x, so that x is going to be 7. All right, so the question is, what is the length of the longest side? Well, the longest side is going to be 6 times x, so 6x is going to be 42, and we do have inches. Got to be careful to get your units in there. All right. That's how you work a problem using an extended ratio. All right, what if I have the equation with two ratios? I think we know that's called a proportion. Proportion. All right, and some terminology related to proportions. A and D are called the extremes. So these two right here, these are called the extremes. And B and C would be called the means. The means and the extremes, you'll always have those when you have a proportion. And of course, to solve a proportion, we use the cross product property. So we cross multiply. All right, so let's solve these two. What are we going to have here? Oh, well, shoot, 9 times 16, that's a pretty big number. Hey, wait, what should I always do? I should put my ratio in simplest form. Why don't I change this to its simplest form, which is 3/4? Boy, that makes my work a lot easier, doesn't it? So now I know that 4x is 48, therefore x is 12. So guys, please, please remember to simplify your ratios before you take the cross product. It will make your life so much easier. Okay, here, I can't really simplify this one, so I'm just going to go ahead and take the cross product, and I'm going to have 15m equals 3 times m plus 1, which is 3m plus 3. So 15m minus 3m is 12m. Equals 3. So m is going to be 3/12 or 1/4. All right, so there's how we're going to solve proportions. How about some properties of proportions? We know if A over B equals C over D, then I can just write the reciprocal of each one, and I'll get B over A equals D over C. And how can you make sure you've written your property correctly? Well, check the cross product. In this one, I've got AD equals BC. Make sure you've got the same when you take the cross product of your rewritten ratio. All right? And what if I just switch the means? Which ones are the means? That would be these two, right? So if I switch the means, I'm going to put C down here. I'm going to put B up here. And once again, if I check my cross products, I've still got AD equals BC. So I know I'm good. All right, here's one you've probably never seen before and might not have thought of. If I have a ratio, if I have a proportion, what I can do is I can add the denominator of each one to the numerator of each one. So for instance, I can add B here and I can add D here, and those two will be true because of the properties of proportions. All right, now that we know those properties, let's solve a few more proportions. Let's see, I know I need to take the cross product. I know I need to simplify my ratios first. Everything's simplified, but hey, what if I do this? What if I switch my means, that's these two, right? What's going to happen if I switch my means? Well, I'm going to have x plus 4 over x equals 8 over 4. How does that help me? Well, now I can simplify this side here. So I'm going to have x plus 4 over x equals 2 over 1, right? So what I'm going to get now is 2. Now I've got nothing left to do but take the cross product. So 2x equals x plus 4. And when I subtract x from both sides, I get x equals 4. So when you're going to solve a proportion, make sure you've simplified your ratios, and if it will help you to apply any of the properties above, you want to do that. All right, so why don't you, oh no, I was going to say pause here, and let's see if you can do this one, but this is not one we can simplify, so we better plunge in here and take the cross product. What do we got? We got x times x minus 5 equals 24. All right, now I'm going to use the distributive property. So I've got x squared minus 5x equals 24. It's a quadratic equation. How do we solve a quadratic equation? Well, we want to factor it if we can. So let's subtract our 24 from both sides. And now let's see, can we factor this? What are the factors of negative 24 that add to negative 5? How about negative 8 and positive 3? X minus 8, x plus 3. So remember, I know that once I have my quadratic factored, I set each factor equal to 0, and that gives me my two solutions. So x is either 8 or x is going to be negative 3, and both of those answers will make my proportion true. All right, if you need to review your factoring, tonight would be a good time to do it. Okay, one more. Scale model of a car. Let me see how well I can do drawing a little car. Probably not too well, but anyway, got to give it a try. Okay, the scale model of a car is 10 inches long. I'm going to call this the length, 10 inches, and 5 inches tall. The actual car is 5 feet tall. So let me draw our actual car over here. So that's our scale. This is our actual car. Car door, windshield. And I can't tell if that car is going frontwards or backwards. Anyway, this car is 5 feet tall. Remember what we said? We need to make sure our units are the same. So how many inches? Let's change it all to inches. How many inches is 5 feet? 5 times 12, 60 inches. Got to make our units the same. And what are we looking for? The length. We're looking for the length. So we're going to call that x. All right, how are we going to figure this out? We're going to use proportions. And I'm going to have to use a little bit of my summary space. Hopefully you'll still have room to write a summary. So how am I going to do this? Well, I got several ways I can do it, but I'm going to take my scale car. I'm going to take the height to the length. 5 is to 10, as 60 is to x. Could I have said 5 is to 60 as 10 is to x? Of course. And I'd still get the same thing because of the properties of proportions. So I want to simplify this now, right? Let me simplify. This is going to give me 1/2 equals 60 over x. So now when I take the cross product, I get x equals 120, and this is inches. So if I wanted to change that to feet, which is probably what I want to do since they gave me the actual car measurement in feet, then I'm going to say x is 10 feet. And that is the length, 10 feet long. Okay? Hopefully you still have room for a summary. Go back and write your essential question, and our next lesson will be on similar polygons.